Thank you very much for inviting me. My name is Stijn Calders, and I'm going to talk about MOMSTER. MOMSTER stands for Mobile Meteor Station for Education and Outreach, and it's funded under the Europlanet Public Engagement Scheme in 2020. I'm working for the Royal Belgian Institute for Space Aeronomy, who takes the lead of this project. And we are collaborating with two other partners. One is the Planetarium in Brussels for the promotion of the project, and the other is the Catholic University of Leuven, who is responsible for the educational material. And I've also put the names on the first slide. So what is MOMSTER? MOMSTER is the educational part of the BRAMS project, which is a science project to observe meteors. In the BRAMS project, we don't observe meteors using visual techniques, but we are using radio techniques. Of course, a meteor doesn't emit radio waves itself, but if a meteoroid, the stone itself, moves through the ionosphere at a very high speed, it leaves an ionized trail behind, and radio waves reflect on this ionized trail. So if you have somewhere a transmitter, it will bounce back on this ionized trail, and it can be received at another place on the Earth's surface. We are using this meteor science to steer the interest of students for citizen science and STEAM activities, as I will explain further down in my project. To illustrate a bit the BRAMS network, so we have installed a transmitter in Durban in the south of Belgium, and when a meteoroid enters the Earth's atmosphere above Belgium, radio waves gets reflected at several places in Belgium and can be detected by one of our about 40 receivers that we have built now in Belgium and the neighboring countries. Why are we doing this? What are the scientific objectives of the BRAMS project? To name a few, because there are a lot, but to name a few, first is to compute the meteoroid flux densities for meteor showers, and also the mass indexes, both for meteor showers and for sporadic meteors. We also want to determine individual meteor trajectories for observation, from observations of the same meteor by multiple stations. We want to determine orbital parameters and so on and so on. So at the basis is a very strong scientific project. However, like I mentioned already, we have about 40 stations installed now, and all these stations are observing 24 hours per day, 7 days per week. So every station is producing about 300 spectrograms of 5 minutes per day. So in total, we are producing more than 10,000 spectrograms for the whole network. Of course, it's not doable to process all this by hand, so we have developed automatic detection algorithms, but these automatic detection algorithms often fail during meteor showers, because during meteor showers, we have bigger particles entering the Earth's atmosphere, which are causing more irregular shapes, like you can see in this example. And for this reason, we decided 5 years ago to launch the Radio Meteor Zoo on the Zooniverse platform. The Radio Meteor Zoo is a citizen science project where we ask volunteers to draw rectangles around everything they think is a meteor. Attracting new people to the Radio Meteor Zoo proved to be challenging, especially if you have a long-running citizen science project like the Radio Meteor Zoo. So we are always looking for ways to promote this citizen science project. And one way was through the Breitek project that we joined in 2019. The Breitek Project, Breitek stands for Bringing Research into the Classroom. The Breitek Project was an Erasmus Plus project where the aim was to co-create educational material. So co-creation means that scientists and teachers are sitting together and trying to bring, in this case, citizen science into the classroom and explaining to the students what scientific research we are doing. So in the framework of this Breitek project, I explained the Browse project and Radio Meteor Zoo to children between 12 and 18 years old. However, we were missing one part. We couldn't really show how these observations of these radio meteors are done, because we didn't have a receiving station at that school. So with the MOMSTER project, we tried to solve that problem, to really to bring also a radio meteor receiving stations into the classroom. So with the MOMSTER project, we had 3 project goals. One was to stimulate STEAM at schools, with the ultimate goal of nurturing students' future career choices towards science, engineering, and technology studies. Also to stimulate the use of citizen science in schools, especially the radio meteor zoo, of course. And for this, we have developed a hands-on meteor education kit to facilitate this for the teacher to talk about the radio meteor zoo in class. And finally, we also want to reach the public. So we want to bring radio meteors or meteors in general to the public observatories, to science centers, to universities, and so on. What are the achievements that we have reached? One is that we have built a brand new meteor receiver. The traditional BRAMS station has a very big antenna, which is not so easy to set up. Has some receiver that is not so easy to handle. And for the MOMSTER project, it had to be easy to set up and to use. So for this, we have developed a much smaller antenna than we have for BRAMS receiving station. And we have also created a receiving box that you see here at the right side. We have put a transparent layer on top of this receiver, such that the students can really look inside and see what electronics are inside the box. And of course, we also developed educational material. We reused the educational material that we developed in the framework of the Breitek project, but we created also new material, and we used the same strategy as what we used for the Breitek project. So we did it in co-creation. So we, the scientists, sat together with the teachers to create educational materials, to fully use the competence of the teachers. Our competence is that we understand the science behind meteors. The competence of the teachers is that they understand how you can bring this in a good way to the students. Moreover, we have organized an art and infographic competition. So the drawing that you see on top of the MOMSTER box, the MOMSTER box containing the antenna and the receiver that I showed before. So this drawing of the space box is made by a student who won this art competition. The same for this roll-up banner. It's also created by a student, and it explains the difference between a meteoroid, a meteor, and a meteorite. And of course, we also brought we sent the MOMSTER box to schools, where teachers are using it now to show to the students. What are the lessons learned from this project? First of all, it's very important for the teachers to be able to link the educational material to the learning goals. So they have to follow a certain lesson plan, and if you want to replace certain lessons by demonstrating radio meteors, you really have to explain which learning goals they achieve with doing that. So this is very important. Another thing is that it's a big challenge, but a fun challenge, to explain what we investigate exactly and why in a language that is accessible for the students. To give you an example, we developed we are still developing educational material for mathematics, where we explain that a meteor should be tangential to an ellipsoid. But you can prove this, that there is a mathematical proof for that, but you also have to explain why this is important and how that we use this in our meteor research. And doing this it's fun to do, but it's not so easy. Also, we learned that we had to collaborate with already existing networks. Some universities in Belgium are well known for educating teachers and explaining them what they could do extra during their lessons, and they are well known, and you really have to collaborate with them to promote the MOMSTER project. And last but not least, the budget we had was €5,000. It's very limited, and it forced us to reuse as much as possible things that we developed. To give you few examples, we recorded a video before the MOMSTER project for a science day, where I explain about meteors. This video we reused in the frame of the MOMSTER project, but also the other way around. So we have developed this receiving box for MOMSTER, and we are using now the same receiving box also to build new BRAM stations. So it works in two ways. So that was my explanation. Thank you very much. And if there are questions, feel free to ask.